In this video, we will learn how to find derivatives of logarithmic functions. For finding derivative of logarithmic functions, we need these two formulas. Derivative of ln of u is u prime over u, and derivative of log of u in the base b is u prime over u ln of b. The best way that we can learn these formulas is to do lots of examples with them. Suppose we want to find the derivative of these functions. Y equals ln of x, y equals ln of x squared plus 9, and y equals ln of sine of x. For finding the derivative of all of these functions, we use this formula. Derivative of ln of u is u prime over u. In this formula, u can be any expression in terms of x. For example, u can be x squared, sine of x, square root of x, or any other expression in terms of x. And derivative of ln of u is u prime over u. So based on this formula, derivative of ln of any expression equals to, put that expression in denominator. If that expression is u, put that u in denominator. If that expression is x, put that x in denominator. Whatever the expression is, put that expression in denominator, and in numerator, put the derivative of that expression. For example, derivative of ln of x is x in denominator, because u in this example is x, so we have to put x in denominator, and derivative of x in top. What is derivative of x? 1. So derivative of ln of x is 1 over x. In our second example, u is x squared plus 9, and based on the formula, we have to write down the expression in front of ln in denominator. U is x squared plus 9. We have to write down u in denominator, x squared plus 9 in denominator, and derivative of that u in numerator. Derivative of x squared plus 9 is 2x. The reason that we have to put u prime, derivative of u in numerator, is because of chain rule. We have to take derivative of inside function. In our third example, y prime is, write sine of x in denominator, u is sine of x. We have to put u in denominator, and in numerator, take derivative of that u. What is derivative of sine of x? Cosine of x. So derivative of ln of sine of x is cosine of x over sine of x. If you like, from trigonometry, we know that cosine over sine is cotangent of x. Let's do some more examples. Consider this function ln of x. This is a bit more tricky question. Note that in this example, this expression is u, and based on our formula, derivative of ln of u is u prime over u. So derivative of ln of x is ln of x in denominator, because we have to put u in denominator, and in numerator we have u prime, which means derivative of this ln of x, derivative of this expression. What is derivative of ln of x? If you remember from the example that we did here, derivative of ln of x is 1 over x. So in numerator we have 1 over x. If you want, you can simplify this answer as 1 over x times by 1 over ln of x, which is 1 over x ln of x. So derivative of the function ln of x is 1 over x ln of x. Now let's do some examples with our second formula that we have here. Derivative of log of u in any base is u prime over u times by ln of b in denominator. For example, suppose we want to find derivative of the function log of x in the base 3. Y prime is 1 over x ln of 3. Note that in this example, u is x, and so u prime, which means derivative of x, is 1 in numerator over u, which is x, times by ln of the base, which is 3. So derivative of log of x in the base 3 is 1 over x ln of 3. Let's try another example. Log of 1 plus cosine of x in the base 10. In this example, 1 plus cosine of x is u and the base is 10. And so y prime is we have to write u in denominator times by ln of base, which is 10, and in numerator we have u prime. But what is u prime? Derivative of 1 is 0 and derivative of cosine of x is negative sine of x. So u prime is negative sine of x. So derivative of the function is negative sine of x over 1 plus cosine of x times by ln of 10. Maybe you wonder why in derivative of ln of u we don't have ln of b similar to log of u in the base b. We expect to have a ln in denominator of this formula for derivative of ln of u. But why we don't have that ln in denominator of this formula? Note that ln of u is log of expression u in the base e. And so based on the general formula that here we have, derivative of log of u in the base e, which is actually ln of u, is u prime over u ln of the number e. But we know that ln of e is 1, and so this formula simplifies to u prime over u. Let's do some more examples to get familiar with derivatives of logarithmic functions. For example, consider y equals x times ln of x. For finding the derivative of this function, we need product rule because x is multiplied by ln of x. Remember that the derivative of f times g, which f and g are two functions, is f prime times g, derivative of the first function times by second function, plus f times g prime, the first function times by derivative of second function. So for finding derivative of the function x times ln of x, first we have to take derivative of the first function, which is x, and derivative of x is 1 times by ln of x plus write the first function, which is x, multiplied by derivative of second function. Remember that derivative of ln of x is 1 over x. So derivative of our function is 1 times ln of x plus x times 1 over x. But you can simplify this answer and write it as ln of x plus 1. Note that this x in top cancels with this x in bottom, so x times 1 over x is 1. Now look at this example, y equals ln of x over x. For finding derivative of ln of x over x, we need quotient rule. Based on the quotient rule, derivative of f over g is f prime times g, derivative of top times by bottom, minus f top function, times by g prime, which means derivative of bottom function, all over bottom squared. ln of x is the top function, and first we have to take derivative of top function. Derivative of ln of x is 1 over x times by g, which is x, minus, write the top function itself, ln of x times by g prime, which means derivative of the bottom function, but derivative of x is 1, and you don't need to multiply ln of x by 1, all over the bottom function, which is x squared. If you simplify numerator, 1 over x times x is 1 minus ln of x all over x squared. Now look at this example, y equals ln of x to the power of 3. We can find the derivative of this function in two different methods. Let me show you both. One way is to choose expression in front of ln as u and use this formula. Derivative of ln of u is u prime over u, and so derivative of ln of x to the 3 is 3x squared over x to the 3, u in denominator and derivative of that u in numerator. You can simplify x to the 2 with x to the 3 from denominator, and we have 3 over x. So derivative of ln of x to the 3 is 3 over x. But what is the other way that we can find its derivative? And actually, this second method is a better way for finding the derivative of this function. Let me here remind you one property of logarithmic functions that we need here for this example. ln of any expression with a power p can be written as p ln of a. Based on this formula, we can rewrite ln of x to the 3 as 3 ln of x. We can bring the power 3 to the front of ln and write it as 3 ln of x. And so, now we start finding the derivative of this function. 3 is just a constant for ln of x, so we have to write down that constant. Based on constant multiple rule, we write the constant, and then we take the derivative of the expression. Derivative of ln of x is 1 over x. If you multiply 3 in 1 over x, we have 3 over x. If you compare the answers, you can see that the answers are the same. I highly recommend you to keep this second method in your head when you want to find the derivative of logarithmic functions. Before doing any differentiation, take a look at the function and check if you can simplify the function. First simplify the function and then take the derivative of the function. In this way, you can find the derivative of the function easier. Y equals to ln of 2x plus 1 to the power of 5 over x2 plus 4. If you want, you can start finding the derivative of this function with this formula immediately by choosing all of these expressions as u. But as you can see, the u is a very complicated expression, and finding u prime for numerator is a bit hard. The better method for finding the derivative of this function is to first simplify this expression and then take the derivative of the function. But how we can simplify this expression? Let me remind you here two properties of logarithmic functions. ln of a over b can be written as ln of a minus ln of b. The other property that we need for this particular example is that ln of a to the power of b p ln of a. By using this first property of ln, we can rewrite this function in the form of ln of 2x plus 1 to the 5th minus ln of x squared plus 4. ln of a over b is ln of a minus ln of b, ln of top minus ln of bottom, ln of 2x plus 1 to the fifth minus ln of x2 plus 4. Now by using this second property, we can bring this power 5 to the front of ln, and so we have 5 ln of 2x plus 1 minus ln of x squared plus 4. Note that so far we just simplified our function, and now our function is ready to be differentiated. Y prime is 5 times by derivative of ln of 2x plus 1. Based on the formula for derivative of ln of u, derivative of ln of 2x plus 1 is 2x plus 1 in denominator and derivative of that in numerator, which is 2. Derivative of 2x is 2 and derivative of 1 is 0. Minus derivative of ln of x2 plus 4 is x2 plus 4 in denominator, and derivative of that u, derivative of expression in front of ln in numerator, which is 2x.